Hi guys, it's time for us to have a little bit more fun. In this lesson, we're actually going to dive into color. So welcome to lesson 3. We're going to look at pigments, understand how foundations are formulated from pigments and how skin tones are formulated from pigments as well. But first, we've got to take a step back and review the basics of color. We're going to look into the color wheel, understand the relationships, and review the relationships between primary, secondary, and tertiary colors. So let's start. Believe it or not, the primary colors we were taught in school are actually not the real primary colors. We were taught that red, blue, and yellow are the primary colors from which we can mix and create all the other colors. But that is not entirely true. If you do some research, you will learn that we actually have 3 color systems in this world. Each color system claims 3 colors to be their primary colors. Now, for the sake of our course and lesson, we are not interested in proving which is the superior color system. Rather, we're going to actually dive into 2 color systems and use the best of both worlds. We're actually going to be a little bit selfish here and take what we need from color system 1 and color system 2. What we should be after really as artists is getting the best possible version of a color. That's really what our goal is, regardless of what system is correct and which one is incorrect. Keeping that in mind, let's dive in. In our presentation today, we're actually going to dive into 2 color systems. We're going to look at the pigments and dyes. We're going to learn about the pros and cons of each. The third color system is really about light engineering, and we're not going to find that very useful for us today, but I will point out how is it different than the 2 color systems which we will examine. So for the 2 systems that we're going to discuss, they're actually rivaling color systems because one system claims their primaries, red, blue, and yellow, while the other system claims red and blue as a secondary color. So you see what I mean by rivaling. Nonetheless, let's take a look. Color system 2 has CMY as their primary color, and you might have heard the term CMYK when you're printing documents and looking into computer graphics, and that stands for cyan, magenta, and yellow. The common primary color between both color systems is yellow, so they agree on that at least. And like I said, instead of discussing which color system is superior, we're just going to look at the pros and cons of each system and make it work for our benefit. The point of difference really revolves around the primary colors. As for the third color system, which we are not discussing today, is the RGB, and that's mostly related to light, monitor screens, and anything to do with technology or displays in general. So the reason why primaries are called primaries, that's because when you mix primaries, you will get all the other colors. They're also supposed to be colors which cannot be created and cannot be mixed up from 2 other colors. Secondary colors, on the other hand, are made by mixing 2 primary colors. So you've got an orange from mixing red and yellow, green from mixing yellow and blue, and violet from mixing blue and red. These are the examples from one color wheel. And in regards to tertiary colors, they're actually a secondary color, but it has more pigment from one of its primaries. So for example, if we said orange, which is a secondary, is 50% yellow and 50% red. But tertiary is actually a little bit more red, so it could be 60% more red, 70% more red, or 70% more yellow, 60% more yellow, and that's the difference. It's just a little bit more percentage. It's kind of like mixing a secondary and a primary together, if that makes sense. And that's how you come up with a yellow orange or a red orange, or a yellow green or a blue green, a red violet or a blue violet. And notice how the name of tertiary colors always has a primary color and a secondary color in it. So it's a red-orange primary, secondary. So everything that we have formulated up until now, or all these colors that you look at now in this jar, are actually true colors. And what true colors are means they have not been mixed up with any gray, black, or white. So they are 100% true. Another word for true color is hue or pigment. And when you hear that, you should automatically understand that these colors are in their truest form with no additional white, black, or gray. Next up is a digital demo on mixing colors. You're going to see me working on both color wheels, the cyan, magenta, and yellow, and red, blue, and yellow. On my left-hand side, I have the cyan, magenta, and yellow color wheel. On my right-hand side, I've got the blue, red, and yellow color wheel. The first thing I'm going to do is start to get my secondary colors. And I do that by mixing two primary colors. To get my tertiary, I'm going to add more of one of the primary. So basically I'm mixing a primary and a secondary together, and you could see that now I have a full color wheel, and you could see that the colors are very different from system A and system B. And let's examine the swatches. You can tell instantly that the oranges on the CMY color system are not very strong. Compare that to the oranges from the other system, and you will see they're a lot more vibrant and richer. What about the green? Look at the greens on both color systems. You're going to see one has vibrant, lovely, delicious greens. The other one, you can't even call that green. And there's one more opportunity here. If you look at the purple on the CMY chart, it looks a lot more vibrant than my purple in the RBY chart. What we're going to do now is replace the weaker hues with the stronger hues from the opposite color system, or the rivaling color system. So that's going to give us a brand new set of color wheel, right? And it has best of both worlds. Wonderful. Now let's take it one step further and start mixing our true colors with black, white, and gray, understand saturation, and understand value. Every color has three main integral parts, and this is inherently with every color. There's the hue, and that is really the frequency that defines the color. What that means, the color red's frequency is much faster than violet. Then you have saturation, and that is really the brilliance of a color, whether it's vibrant or dull. Value refers to the lightness or darkness of color, so that is controlled by adding white, black, or gray. These are the three integral parts or components of a color. When you're adjusting colors on Instagram or Adobe or Photoshop or any of those softwares, you're always going to see three controllers for color, such as my visual example on this slide, hue, saturation, and lightness. So that's kind of what it refers back to. You'll start to understand and see this a lot better when we visually illustrate in our next slide what the difference is and the meaning of saturation, value, and all that jazz. Here, you'll notice the original in our first jar with its original true colors or hues or pigments. Then in jar A, this is where we've actually desaturated them. We'll talk about desaturation a little bit later, but it's literally mixing the opposite color on the color wheel together with it, and that's how you desaturate or you dull it. On the other side, B is oversaturated, and you could see how vibrant these look when they're oversaturated. By default, a hue is a true color, like we said, and is the purest form. Now let's look at the color when we add black, white, or gray to it. In jar A, we have all the shades, and shades refer back to a true color that's been mixed with black. So for example, the true red, when mixed with black, becomes a shade of red. We also call it maroon. And if you look in jar B, these are the tints of colors. So a tint of red, also known as pink, is basically red mixed with white. And when you add black and white or gray, it gives you a tone of that color, so a tone of red. You can see in jar marked T,